Ready to sparge? This is as simple as changing a couple of valves. Water that has been prepared and heated for sparging in the hot liquor tank or sparge vessel needs to flow to the top of the mash. What we'll do is open the valve from the sparge vessel. We no longer need the wort from the bottom of the mash to circulate back to the top, so we'll close that outbound valve. We do need the wort from the mash to head in the direction of the boil kettle, so we'll open the valve to the boil. That's it. You now have sparge water joining the same plumbing that the wort was circulating through. Like the wort, sparge water is being forwarded to the pump, where it is pushed all the way to the same whirlpool at the top of the mash, and at the same pre-adjusted rate or any other rate you choose. Wort is now flowing to the boil. Strike up the burner under the boil and continue your recipe. All during the entire operation, the brewer can choose to allow the versatile onboard controller to record every step as it is being performed by the brewer in perfect clock time. The brewer can assign a file name to the brewing session and save the file to the controller's memory card. Temperature settings, pump activations, input commentary, and every step of your process can be duplicated by the controller simply by asking it to replay the file at a future brewing session. View the files and even upload them to a laptop spreadsheet for printing using the USB port. Such capability gives the Brew Magic owner a virtual brewing assistant to help assure precision, repeatable brews every time. Let's meet up with some friends and talk some more. Welcome to the Brew Magic Test Lab. We've invited some guests and are about to brew a batch of pale ale and show off some new programming.
Make sure we've got good equilibrium going on in here. So we're backfilling. We're allowing the sparge tank to fill the plumbing from the bottom up. Okay, right. All right.
Meet Mr. Rick Harold, master home brewer, as well as professional brew master of the Maumee Bay Brewing Company.
Just kind of see what technology has become at this point where you can program it to do what you want, and with a minimum of personal override, assure repeatability and consistency in the brewing process.
Yeah.
It'll be very, very fascinating to see how this can perform on a mid-level compared to the two extreme levels that I'm used to, with much higher technology than both of the other levels that I've used put together.
Meet Mr. Matt French, Brew Magic home brewer, electrical engineer, and master developer of Sabco's controller system programming.
What? Finished? Okay. Ready to begin. Right away it starts a clock, sort of a master brewing clock. You don't have any control over that. It's keeping track of how long you've been doing this. Push these buttons to turn on the pump. Set your
Making it
at the exact time. It's going to record what's happening, what's really actually happening will get recorded inside of here.
Just lay in this hopper down in the basement all night long.
Oh my goodness.
Oh yeah. It's unlike the old days in which you are relying on a pile of accumulated brew notes, trying to read longhand about the notes that you might have taken 15 batches ago, which have probably been splashed and have been smeared all across the text. Well, right in here, it's all locked up for you. You don't have to write anything down. All you have to do is retrieve the information, and to me, that sounds absolutely fantastic.
The computer's telling us we're right now at 108.5, so I'm going to enable the heat. Use burner. The electric heat exchanger in here is not capable of raising the temperature that far. So we're going to turn on the propane burner.
So this tells you right there, you go ahead and start the burner, and that's what we will do. The burner is going to be used to assist in getting up to mash temperature. And once that's done, the controller is going to tell you to turn the burner off and that it's going to take over and use the electronic heat exchanger to bring it up the last 2 or 3 degrees and lock it down so that it doesn't fluctuate.
Regulating just perfectly now.
Yep.
This thing, you know, and we had to fiddle with snot.
We've got a real nice slow turning whirlpool in here. We're maintaining about an inch above that grain bed. It's blending the temperature in that top 1 layer inch of liquid and pulling it uniformly through the grain bed to that centrally located siphon. So what that does is it blends away any stratification of heat that you may have in this mash kettle, and from top to bottom, left to right, it's all unified temperature. It's really a hands-off situation at this point. All we're doing is monitoring. There's no stirring. I don't need this anymore. I just wanted to make sure that we had a nice even blend in that top layer, and we do. And I'm not about to stir it because all of the system's going to do the stirring for me through recirculation. So my job is done except to monitor the temperature.
And go and open up a beer.
And go and open up a beer. That's a great idea. I like the way you think, Rick. It takes a brewmaster to understand how those things
It takes a
happen.
one-track mind.
A one-track. Here. What are you drinking, Dan?
Mendocino, Imperial.
That sounds pretty good. What do you got, Matt?
This is our friend from Dogfish Head is 90-minute IPA.
90 minute. Oh, that's a subtle brew. That's,
Should be a little
that's some
hoppy.
superior stuff. Very good. Mr. Rick Harold.
This here would be a Clipper City Oktoberfest.
Oh, very nice.
Quite tasty.
Very good.
Good choice.
Very good.
Stabilize right at 122 like we want. Keeping track of temperature, mash temperature. It's gonna plot it out. Start at room temperature water. You're gonna watch it climb and then stabilize out when you hit your target temperature. And it's recording all of this onto a memory card.
Since we're doing an American Pale Ale, I recommended that we go up to 152 degrees because that mash temperature will affect the extraction level of the dextrins. And your lower temperature will extract fewer dextrins, which is fine for a Pilsner beer, light and easy drinking. But for a pale ale, you want a little bit more body. Body is created by dextrins. Dextrins are extracted by a slightly higher temperature. And so I just recommended that we go up 2 degrees.
Terrific. All right.
See how it's not very cloudy? It's very clear. Earlier it was a lot more cloudy. And that decreases over time because the grain acts as a filter.
Yep, we got a static filter bed and it keeps recirculating, so the runoff is absolutely spectacular into the boil. And that is just gorgeous.
I'm addicted to the smell.
Isn't it fabulous?
And what brewer wouldn't be?
What we've been doing since the last few minutes is standing around, and the computer has dialed in on this 152 degree target. You can see we're actually at 151.5 degrees. There's nothing to do here. We're just watching the computer maintain this temperature. We're not doing anything with the propane burner. It's self-regulating. Now let's go to page 2 and you can see each horizontal line represents 2 degrees. And the black line is our actual temperature over the last few minutes. So there's very little fluctuation. Once the computer's zeroed in on that temperature, it's held it very steadily.
Very good.
It's a small brewer's dream because the best you can hope for is like a variance, within 2 degrees, plus or minus 1. And you're what, a half a degree off?
Degree.
Yeah.
Nobody's ever going to quibble about that.
Yeah, look at that. Here's our target temperature here, 152, right there. And here's our actual temperature, 151.5. And it'll keep adjusting until that 152 is nailed right in the middle.
That's close enough.
Yep.
As far as this brewer is concerned, that's close enough.
Very cool. And we're just watching it happen.